So today we've got assignment 81. And assignment 81 is all about solving systems of inequalities. 81, systems of inequalities. It's been a while since we graphed inequalities, but remember when we had something like 3x plus y is less than 3, we said the first thing we wanted to do was to turn that into an equal sign. So 3x plus y equals 3. Now I can graph this by whatever means I'm most comfortable with. Since this linear equation is in standard form, I like using x and y intercepts. If I plug in a 0 for x, I see y is 3. If I plug in a 0 for y and divide both sides by 3, I see x is 1. So I've got these points, and I've got 1 at 1, 0, and then I've got 1 at 0, 3. And so I'm going to connect these. Now is when I need to go back and look at that inequality. So there's that inequality sitting there, right? And we're saying, when is the line below the horizontal line y equals 3? Now, I'm not sure what that means in this picture, but I do want to say, after you graph the line, or after you find, after you graph the line, you need to determine, is it dashed or solid line? And the way we know it's a dashed line is if we see this, or this, or this. And we know it's a solid line if we see this, or this, or this. Well, I see one of them, and so I know that I'm going to have a dashed line. Okay? That dashed line means I go up to that line, but I don't include the values on that line. The line itself is not included, which is why it's dashed. If I want the line included, that's what these are for. These say that line is included as well as all the other points. Now, the third thing we need to do is to figure out the shading. So we're going to test a point to determine where to shade. I like using 0, 0 as a test point, and the only time you can't use 0, 0 is when the graph passes through 0, 0. But as long as the graph doesn't pass through 0, 0, you can use 0, 0 as a very easy test point. If the graph does pass through 0, 0, then I look for another point, either on the x-axis, so there's a y equals 0, or on the y-axis, so that x is 0, that I can use as a test point. Well, let's see what happens when we plug in 0, 0. And again, we're plugging it into the inequality. I plug a 0 in here and a 0 in here, and I got 0 is less than 3. Is that true? Why, yes. And since this point was true, that means that every one of the infinite number of points on that side of the line, that'll be true. If we hop to the other side of the line, and let's say instead of testing 0, 0, we had tested 2, 0. If I plug a 2 and a 0 in, I end up with 6 over here. Is 6 less than 0? Is 6 less than 3? No, 6 is not less than 3. This is a no. So when I get a no, I don't shade the side with the no, I shade the other side of the line. And when I get a yes, I shade the same side of the line. Okay? So my shading, and it really does mean any ordered pair over here is going to make that statement true. That's why when we're asked to write, to solve these, the solution is always a picture, because that's our way of saying all these points. Okay? I mean, you could spend some time writing the infinite number of points, but I'm not really keen to. Okay, so there we have graphing an inequality. What about graphing a system of inequalities. So a system of inequalities, the solution is where the graphs overlap. So I can't wait to do that, but I kind of want to, let's have you do some basic inequality graphing. So y greater than or equal to negative 2x plus 8. Okay, pause the video and please graph that nice, gentle, linear equation. Hey, welcome back. Um, so, I know it's going to be a solid line, and I know I've got a linear equation because it's y equals mx plus b. I know the slope is negative 2, and the y-intercept is 8. If I were to try and find the x-intercept, I would plug a 0 in for y, and I would add 2x to both sides, and then I would divide by 2 and get x equals 4. But you could also do this method where you say, all right, I'm starting up here at 0, 8, and I'm going to go down 2 and over 1, so I have 1, 6. That works too. And then we said solid line, and finally, test a point like 0, 0, 0, 0, I'm going to have 0 is greater than or equal to 8. Well, that's not true. No. So I shade over here. Now, I know that there are many of you who say, well, I just look at the direction of the inequality, and it says y values greater than the line. And so those values are here. And that's generally fine, but my experience is that we run into problems where even those students who've always done that suddenly aren't sure which side, or they feel like they're sure, and then they get the problem wrong because their intuition wasn't correct. So just like we did with inequalities back in Algebra Basics, I'm going to say, really, it's not such a big deal to test the point 0, 0, just so you can know you're going to get it right. I recommend doing it. Okay. Next, how about this one? Y is greater than x squared minus 3x minus 4. Will you please graph that inequality? I hope you're thinking about turning that into an equal sign because it's so much easier when it looks like a familiar thing. And so we've got x minus 4 and x plus 1. And so we could say, okay, we've got x-intercepts at 4 and negative 1. It's an up-pointing parabola. And we see a y-intercept of negative 4. So 0, negative 4. Of course, you could find this vertex point if you wanted. I don't particularly need you to. I just need you to graph the parabola with 3 points on it by going halfway in between the x-intercepts. So 4 plus negative 1 divided by 2. That's going to be 3 halves. So we know the x value here is 3 halves. And if we want to know the y value, we take this 3 halves and plug it into each of those places. 3 halves minus 8 halves, that's going to be negative 5 halves. And 3 halves plus 2 halves, that's going to be positive 5 halves. And so I end up with negative 25 fourths. Okey-doke. Now, is it a solid line or is it dashed? Well, look at the inequality. It doesn't have a equals to with it, and so it's dashed. Okay. Now, finally, the shading. So if I plug in my test point, my preferred test point of 0, 0, I'm going to have a 0 over here greater than 0, 0, minus 4. Is 0 greater than negative 4? Yeah, so that point works. In this situation, what we're saying then is that all the points on this side of the line work, which means inside the parabola is where we find our solution. Okay? All right, last one before we jump into systems. 9 is x minus 1 squared plus y minus 2 squared. Yeah, what's that? Because it's been a while since we did that. We saw things that looked like this in the functions unit. And you know, we were used to seeing it like this. What's that the equation for? Yep. It might be a good time to go back through the notes with the final exam coming up, and circles definitely on it. So we know this is a circle whose center is at 1, 2, inside is opposite land. And remember, this is r squared, so our radius is 3. So I'm going to graph the center, 1, 2, and then I'm going to go 3 this way, and I'm going to go 3 this way, and I'm going to go 3 this way, and I'm going to go 3 this way. Now, how did I get these y values? Well, I just either added 3 to this x, subtract 3 from that x, or I added 3 to this y, or I subtracted 3 from this y. I see because of the inequality that I'm making a dashed line. And now I want to know, is my shading going to be inside or outside? And I think 0, 0 is inside, but I'm not entirely sure. So if I'm really not sure, and I want to check just to be sure, something that's further away, like, I don't know, 5, 0. So 5 minus 1 is 4, 4 squared is 16, plus 0 minus 2 is negative 2 squared is 4, and I get, I get 9 is less than 20. And so that point is a yes, which means all the points out here are a yes. Let's see what happens when we test 0, 0. According to my sketch, 0, 0 is not part of the solution. I should get a no. Let's see if I get a no. If I plug in a 0 here and a 0 here, oh, well, I end up with 1 plus 2 squared is 4. And so I have 9 is less than 5. Well, no, that's not true. And that's why we shade on the outside. Okay, so now let's do a system. And so for a system, like a system of equations, the point of intersection is the solution. Well, systems of inequalities, it's the overlapping region is the solution. Okay? And so here's what I mean. Now, if I look at something like y greater than or equal to negative 2x plus 8, and y is greater than x squared minus 3x minus 4, and I graph these things, we've got 8, and we have 4, no, 4. So 4, and it was a solid line. And I tested 0, 0, and I got 0 is bigger than or 8, and that's not true. So I shaded over here. Okay, and then in a different color to keep my brain sane, I graphed here, and as I recall, this was minus 4 and plus 1. So I had this one, ooh, and that one. How convenient. And then I had parabola. Okay. And when we shaded this parabola, oh wait, it's a dotted, dashed line. So let's dash it, and don't forget to label. Negative 1, we've got that, this was 0, negative 4, and I'm going to continue this. Okay, and now let's test 0, 0 here. And so we had 0 is bigger than -4. This point was a yes, so we shaded everything inside the parabola. Now, it's kind of messy. It's kind of hard to see. So where's our solution? Well, our solution is where the black and the blue are overlapping. And so that happens like this. Now, I need some way of knowing what the solution is. And that means I need to be able to see it. Whether you use different colors, whether you use different shading, doesn't matter to me. What I need, though, is to be able to look at it and say, yes, this is where the overlapping occurs. Okay? So, yeah, make sure I can see the overlapping. I do want you to label some points on each graph as a part of the process of graphing the points. There is one other thing I'd like to do. I occasionally ask where these points are. We see one of them is here, but I'm not sure where this one is. And sometimes knowing those points of intersection, yeah, that's kind of important. So how do I find those points of intersection? Well, a point of intersection happens when a curve meets a line, when the y values of the curve are equal to the y values of the line. So I want to set the y value equal to the y value. -2x plus 8 equals x squared minus 3x minus 4. So I'm going to add 2x to both sides. I'm going to subtract 8 from both sides. When I add 2x to both sides, I get minus 1x. When I subtract 8 from both sides, I get minus 12. So this factors as x minus 4, x plus 3. So x equals 4 and x equals -3. Well, I think this is Kukla being sleepy. That's supposed to be a 4, 0, not a 0, 4. So that one I've already got. But if I didn't know where that was, I could take that -4 and plug it into this equation, not inequality, equation, or I could take this 4 and plug it into this equation. Plugging 4 in here, -2 times 4 is -8, plus 8 is 0, and that's that point. What about this? This must be the -3. 2 times -3, no, -3 times -2 is positive 6. 6 plus 8 is 14. So this point over here is going to be -3, 14. Okay? There is a type of math that really depends on us finding these points of intersection. Sometimes they're called vertices if the shaded region becomes an enclosed figure. And linear programming requires us to find those points of intersection. I don't think we're going to get to linear programming this year, but yeah, so sometimes I need those points of intersection. All right, so here's yours. Are you ready? It's kind of exciting. 3x plus y is less than 3, and 4 minus y is less than or equal to 2x. So, graph the inequalities and find the overlapping region. Come back when you're done. I wish I could get that glare off that. Hey, welcome back, everyone. Again, from standard form, remember ax plus by equals c. From standard form, I always prefer to use x and y intercepts, because if I plug a 0 in for x, I see y is 3. And if I plug a 0 in for y and divide both sides by 3, I see x is 1. And really, that's so much faster and so less prone to making mistakes, sign mistakes when I subtract, than rewriting the standard form into slope-intercept form. So my graph passes through 0, 3, and 1, 0. Dashed line And what side do I test? Well, if I plug in a 0, 0, I have 0 on this side is less than 3. Yeah, 0 is less than 3. So there's my shading. Now, what about this one? Well, so, yeah, I kind of don't want to do the intercepts here. I kind of want to get this in y equals mx plus b. But how about this? Let's compromise. I'll add y to both sides. And now I'll have 4 is less than or equal to 2x plus y. Oh, okay. Well, I feel like I can do that. We've got x and y, a 0 here for x means y is 4, and a 0 here for y, and divide both sides by 2, I get x equals 2. So 2 here and 4 here. Now, that's going to be a solid line. This was 4. It's going to be 4 times as big as that because that was 1. Often what happens is students don't extend the lines far enough, so they actually miss the solution region. So don't be afraid to make these graphs big and extend long. Okay, so let's see what happens when we test a point like 0, 0. If I plug in a 0 here and a 0 here, I get 0 is greater than or equal to 4. Well, no, that's not true for the blue line. So now I've got this. Okay, so where do they overlap? Well, you don't see the overlap unless you extend far enough to see, oh, here it is. I'm bounded here, and here, and in here. Okay? So, extend, extend, extend those lines. All right. So let's do a couple more of these, and let's make them pre-Cali. Because we know how to graph all kinds of things that are not linear equations. How about this one? X squared plus y squared is greater than 1. X squared plus y squared is less than 4. Will you graph that one? Yeah, they're both circles. They're both circles with the center at the origin, right? Because we're looking at x minus 0 squared plus y minus 0 squared equals 1. Centers at the origin, and the radius, this isn't the radius, this is radius squared. The radius is 1. In this case, we've got x minus 0 squared plus y minus 0 squared equals 2 squared. So we know the radius is 2. So this is a very interesting drawing. One of our circles has a radius of 1, and it's a dotted line, or a dashed line. And what about the shading? If I plug in 0, 0, I get 0 is bigger than 1. No, that's not true. So I'm shading outside like a little sun. Okay, and now, what about the other one? Well, the other one is also centered at 0, 0, but it has a radius of 2. And negative 2, and negative 2. And it's also a dashed line. And now where do I shade for this? Outside of the blue or inside of the blue? Well, if I plug in a 0, 0 here, 0 is less than 4. That is a yes. So my shading for the blue goes to the place where I say, I need a blue marker, because that one don't work anymore. Here's a blue marker. So where's the overlap? Well, I don't see any overlapping in here. I don't see any overlapping out here, but I do see blue and black here. So this is where it is. We've got dashed on the inside and dashed on the outside. Make sure I can see and recognize and understand without your help, where the solution is supposed to be. Okay? All right, how about this one? What if we had y is greater than or equal to x minus 2 and y is less than or equal to 4 minus x squared? Will you find the solution to that system? We'll do one or two more of these, and then we'll move on to doing some going backwards problems. Hey, welcome back. So I've got this linear equation, y equals x minus 2. So I know 0, negative 2 is on there. And if I put a 0 here and add 2 to both sides, I get 2, 0 is also on. Because of this, my line is solid. And if I test 0, 0, I get 0 is greater than or equal to negative 2. Well, it is true. 0 is bigger than negative 2, and so I shade here. Now, what about this one? What can I say about this one? Well, I know it's a down-pointing parabola shifted up 4. So I've got 0, 4. Some people like factoring this 4, 2 minus x, 2 plus x. And so they find this point and this point. But other people, no, they're not the factoring sort. They do negative x squared plus 4. They do transformations, and they go back to our reference points. And which order do we do it in? PEMDAS. So I multiply all those y's by negative 1, and then I add 4 to them. And I can see negative 1, 3, 0, 4, and 1, 3. Oops. 1, 3, and negative 1, 3. Look, there's that symmetry. Good, so I got the graph. It is supposed to be a solid line. Now what about 0, 0? Does that work? 0 is less than or equal to 4. Well, yeah, that's true. So my blue shading is inside. And so for us then, the solution goes like this, and like this, and is this in here. And again, you know, I've done a lot of linear programming in math classes, and so I'm going to say, yeah, let's see how about finding those points of intersection. I mean, if you did these, you don't necessarily know that your parabola intersects the line at 2, 0. So we're going to find both of these points of intersection. How? Well, at both of these points of intersection, the y values are equal. So I want to set this y equal to this y, which means this stuff should be equal to this stuff. So let's do some math about that. We've got x minus 2 equals 4 minus x squared. I'm going to move everything over there, add x squared and subtract 4. And the reason I'm doing that, even though I know many of you always want to move everything onto this side, is I don't want to factor with that negative x squared. I've been watching a lot of you make a lot of mistakes when you try and factor with a negative leading coefficient, and I don't recommend it. So move everything over there so you can have a positive x squared plus x minus 6 equals 0. And I get x plus 3 and x minus 2. So I know x equals negative 3 is one of my points of intersection. But what's the y value there? And if I plug my negative 3 back into either equation, negative 3 minus 2 is negative 5. So this is negative 3, negative 5. Or I could plug my negative 3 in here. Negative 3 times negative 3 is positive 9. 4 minus 9 is again negative 5. We also have x equals 2 as an x-intercept. 2 minus 2, 0. Okay? Okay. Find those points of intersection by setting the equations equal to each other. Okay, what can you do with this one? y is greater than or equal to 0, x is between 8 and 3, and y is less than or equal to the square root of x plus 1. And curiously, this isn't usually the problem that people have difficulty with. They know their transformations. They know this was shifted 1 to the left. And so we have those points. Okay, and our graph. And it is a solid line. But what side do I shade? So if I plug in 0, 0, I get 0 is less than or equal to square root of 1. Well, yeah, 1 is bigger than 0. So this is my solution. Now, what about down here? Does it, yeah, I'm not quite sure. So let's try something like 0, negative 1. If I plug in 0 here and negative 1, well, yeah, that works, because then I've got 0 is bigger than or equal to negative 1. So I'm not bounded by the x-axis. This goes down forever. Okay? Now, what about these other things? Well, back on the first day of the semester, we said y equals a number is a horizontal line. And we said x equals a number is a vertical line. So here's y equals 0, can be equal to, so it's solid, okay? And if I test a point, I can't use 0, 0 because the line passes through 0, 0. Let's use 0, 1. So there's no x's, Mr. Cooper. Yeah, I know, so you don't have to worry about plugging that in anymore. It's freedom, child, freedom. And then 1 is the y value. So I plug 1 in here. Is 1 bigger than 0? Sure it is. And so I shade that side of the line. Now, what about this? Well, x is a vertical line at 3. So here's 3. Here's my vertical line. Yes, my vertical line is solid. But what side? Well, if I test 0, there's 0. If I test a 0 in there, 0 is not bigger than 3. So this side of that vertical line does not work. So I'm going to shade that away. But don't forget there's this as well. X is less than or equal to 8. So x equals 8 is this vertical line. And I need x values less than 8. Well, x values less than 8 are over here. So the shading for this inequality is all the stuff in between x equals 3 and x equals 8. Remember, we had the red shading, all the y values that are positive or 0, and then we had our shading for our square root function. So where's the overlap? Well, it goes from here to here to here to here and back again. And so we get that, yeah, it's not a polygon because that's not straight, but we do get an enclosed figure here. And again, finding these corner points is very, very important for those of you who will be running into linear programming. We're not gonna, so I think I'm gonna not worry about that. Though I will say that the x value here is 3, and so the x value here is 3. So if I plug in a 3, I get 2. And over here, the x value is 8, so the x value is 8 here. So if I plug in an 8 here, 8 plus 1 is 9, square root of 9 is 3. So without too much suffering, I can get an ordered pair, and I can already see that ordered pair. This, of course, is 3, 0, and this one is 8, 0. Okay. All right. Do you need another one of those, or are you okay? Okay. So, kind of want to do this one. You know, I don't think I put anything this thrilling on our assessment, but those of you moving on to calculus, I don't know that that's a bad thing for you to explore. Okay, so here we've got our absolute value v that's been shifted left to, and I could, of course, say also down 4. So absolute value v, I've got -2, 4, and yeah, so what happens here is some students go like this, and some students go like this, and some students go like this. And how do we know which one we're supposed to do? Well, it would really help if I knew my y-intercept. So I'm going to plug in 0 for x, so I can have another point to graph. So if I put in a 0 for x, I'm going to have absolute value of 2, which is 2. 2 minus 4 is -2, and -2 works for me. 0, -2. So that and that. And again, we have solid line. I can always use symmetry to find this point over here, -4, -2. You could also graph this using your transformations. We want the solid line. And what about the testing? Well, if I test 0, 0, 0, 0, I'm going to have -2 is less than or equal to 0. Yeah, that's true. So this is a solution. So everything inside that v is going to be a solution. Well, what about this one? You know, this is, I know that x, absolute x equals y is this, and I know x equals absolute y is that. Now, what about that -3? Okay, so if I plug in y equals 0, if I plug in a y equals, let's just really, 1 minus 3 equals 0. If I plug in y equals 0, x, there we go. If I plug in y equals 0, I get x equals 3. So I have 3, 0 on this graph. Okay, what else do I have on the graph? Well, if I plug in a 0 for x, I've got y minus 3 equals 0. So then y equals 3. What about this point? Well, how do I know? Well, so there are some people, remember, who wanted to use transformations here. And what I said is, you can, provided you turn and look this way. This is up. Therefore, moving that way is down. So, did I do that wrong? Is it supposed to be? No. You know, I'm just gonna write both the positive and negative components and see about graphing these, I think. Yeah, this is why I didn't want you worrying about it, because I'm not going to do this to you on the test. So we've got y minus 3 equals x, and we've got y minus 3 equals -x. So where do they break? They break at 3. And then this one is y equals x plus 3. That's this line. 3. And we've got y equals -x plus 3. Yeah, that's this line. Sorry, got scared there. Don't do enough of these. So then I want to test my 0, 0 point. Great, 0, 0. And I see what happened here was, I understand why I got confused, because I moved those numbers over. Yeah. Okay. Now, we're just going to walk away, because the problem I had really intended to do was not the one I had written. It was instead this one. Absolute x plus 2 is less than or equal to y, and absolute y minus 3 is less than x. Now I get the absolute value v's. So here's the thing. In order to get the v shape, I need an x and a y. What I had before was this. And this is not, no y's here. This is going to be absolute x plus 2 equals 4. And so then we write the positive component, and we write the negative component, and we solve, and we see, okay, that's going to be x equals 2, and that's going to be x equals negative 6. And what we're saying is that our answer are these two vertical lines, negative 6 and 2, and if I plug in 0, I get into the inequality, I get 0 is less than, 2 is less than 4, and that's true. So I'm looking at this. This original inequality that we had makes that picture. But I had really intended these V's and was getting tripped up when I was trying to apply the V method to the things that weren't V's. So I apologize for the confusion. Here, we definitely have our absolute value V shifted left 2. So we know that this is negative 2, 0, this is 0, 2, and this is negative 4, 2. And here, when I plug in a 0 for x, I see that y equals 3, 0, 3. But if I plug in a 0 for y, I'm going to get x equals 3. 3, 0. Now, I'm thinking that this is absolute minus 3. This is inside the absolute value function. And so I'm moving, and inside is opposite line. So instead of negative 3, I'm going to positive 3. But I think if it's supposed to be this way, I need another y value at 3. So let's take a look at solving that. Y minus 3 equals x. So I write the positive component and the negative component. Okay, so y minus 3 equals x, and y minus 3 equals negative x. So I get y equals x plus 3, and y equals negative x plus 3. Well, this line is y equals negative x plus 3. This line is y equals positive x plus 3. And so yes, my v's go in those directions, though you would probably like it much better if I did that. And then the question is, where was I supposed to be shading? So if I plug a 0, 0 into this one, I get 2 is less than 0. This is a no. That means that everything inside the V is a yes. And here with the blue one, if I test 0, 0, I get 3 is less than 0. So again, this is a no. So all my shading is inside that V. And so my final solution then is this overlapping region there. Okay? Okay. Well, sorry for that torment. You know, it was really just for me. Let's take a look now at going backwards. Let's imagine that we have this system of inequalities graphed so that our solution is here. Not past that, but here. Okay, so I see a bunch of boundaries here. In fact, I've drawn the picture wrong. In fact, I want that to be 4. I want this to be 3. That's negative 4. And up here, dashed, that's 0, positive 4. And where's my shading? My shading is here. Okay, so what boundaries do we have? Well, we're bounded on left and right by these vertical lines. One of them is solid, one of them is dashed. We know that x equals a number is a vertical line. So this is going to be x equals 0, like this. And with the equal to, because this is a solid line. On the other side at positive 3, we've got a dashed line. So I want that. This inequality expression gives me these two vertical lines. But I still have two more boundaries, don't I? I've got this boundary down here, which is again a linear equation that passes through negative 4 and 4. We see that the y-intercept is negative 4, so we know that b is negative 4. And I notice that I'm going up 4 and over 4 to get to that point. So my slope is 1. 4 over 4 is 1. So then I can say, all right, well, y equals 1x minus 4. But now, is this supposed to be an equal sign, a greater to or equal sign, a less than or equal to sign, a less than sign? What symbol should I have here? Well, 0, 0 should be a solution. So if I plug a 0 in here and I plug a 0 in here, I'm going to have 0 and I'm going to have 4 because the absolute value of negative 4 is 4. And I want this to be a yes. So I need to put a symbol here that makes that point be a yes. And there's my symbol. Now, why do I know this instead of just that? Well, I see the solid line, and the solid line requires that. So this is my value. Again, we're going with, what? No, it's not absolute value. Thank you. That's much better. We're going with this less than because when we plugged in 0, 0, we had 0, no symbol, 0 minus 4. So we had 0 and negative 4, this one. And we want this 0, 0 to be a solution. So in order for this to be true, see, it's good to check your work. We should have this inequality. But because this is a solid line, we need that inequality symbol. Oh, okay. Y values that are bigger than that line is what some students say. Nice. So what about this last one? This boundary here. Well, I see the y-intercept at 4. I'm going down 4 and over 4. And so I have y and negative 1x plus 4. But what inequality symbol? Well, I'm dashed, so it's not going to be with an equal to on it. And let's plug in 0, 0 as a test point. Now I've got 0 and 4. I want this to be a yes, so I need that symbol. That's the symbol I need. So that's my system of inequalities. Okay. All right, well, let's do a couple more of those. So what if I had this circle 0, 0, 3 and a line 0, 4 and 2, 0. And then the shading is here. Okay. Can you do it? I like to think you can. Give it a try. Come back when you're done. I'm looking for the system of inequalities that makes this shaded region. Okay. Hey, welcome back. So the circle, x minus 0 squared plus y minus 0 squared equals, the radius is 3. And so I might write x squared plus y squared and a 9 over here. But what about the inequality? What am I supposed to put? I know it's got this in it because this is a solid line. But is 0, 0 a solution or not a solution? Well, 0, 0 is not a solution. It's not in that shaded region. So when I plug in this answer should be no. So if I say that 0 is bigger than 9, yeah, I'm pretty comfortable saying no. So then the first inequality for my system is going to be x squared plus y squared greater than or equal to 9. Okay, so when I plug in a 0, 0, oh, but wait a minute. I wasn't paying attention. This shading is actually inside the circle. 0, 0 is a yes, not a no. Oh, there we go. So, it's good to think. I'm just always pleased when I've done some thinking. And then we have this linear equation. We're shading over here. My linear equation seems to have a y-intercept of 4, and I go down 4 and over 2. Down 4 and over 2, so my slope is negative 2. My b value is 4. So I can write y negative 2x plus 4. But what about the inequality symbol? That's what I'm wondering about. Well, this time, there's no shading to the left of the line. And that's what was throwing me off before. I was trying to apply the shading yes or no based on the line as opposed to what I see in the circle. So based on the line, 0, 0 is a no. So 0, 0 plus 4, this needs to be a no. So I gotta go that way. All right. And there's my system of inequalities. Okay, how about one last one, and we'll call it a day. We'll have a circle again, and we've got a parabola. And I know that this 0, 0, and this is 1, 1. And I know that this point is 4, 0, and this point is 0, 4. And the shading, you're going to love the shading. The shading is here. Okay? All right, so let's get to work. We've done shading inside the circle. The circle is centered at the origin. The circle has a radius of 4. And so I get this. Now, what's the direction for the inequality? 0, 0 is a solution, so I want 0 to be a yes, which means I have to go that way. No, silly, that way. Why the equal to? Because of the solid line. So I've got x squared plus y squared is less than or equal to 16. That's my first one. My second one is this parabola. And the vertex, x minus 0 squared plus 0. And I'll plug in this point to solve for a. 1 equals a, and minus 0 squared plus 0. And I get that a equals 1. And so I end up, when I simplify, with y and x squared. But which way do I shade? Well, I'm going to actually, because the parabola passes through 0, 0, I'm going to use this point down here, negative 4, 0. You could certainly use that point, or even that point, but I'm just going to use this point. So if I plug in a negative 4 here, I get 16, and I get a 0 here. 0, 16, and I want this point to be part of the shading for the blue, right? The blue comes all like this. So this point is a yes for our blue. This needs to be a yes. So I want that, and because it's solid, I want that. So there we go. There's my system of inequalities. All right, well, go practice this, and I think I'll look at a couple more of those tomorrow or in the next video, whenever you end up watching. I hope you have a wonderful day, and I'll